Hey guys, welcome back to my YouTube channel. In the last video, I discussed about indeterminate form 0 over 0 and infinity over infinity. So for this video, I'm going to discuss about the other types of indeterminate forms, 0 times plus minus infinity and infinity minus infinity. If the function is in the type of 0 times plus minus infinity or infinity minus infinity, you write it in the form 0 over 0 or infinity over infinity and then apply the LHospitals rule. So LHospitals rule works great on the two indeterminate forms 0 over 0 and infinity over infinity. So let's again define LHospitals rule. It is applied by taking the derivative of the numerator and derivative of the denominator separately, not the derivative of the quotient, or the limit of f of x over g of x as x approaches to c is equal to the limit of f prime of x over g prime of x as x approaches to c. Now let's evaluate some limits. We'll start with the indeterminate form 0 times plus minus infinity. So we have here the limit of x times ln x as x approaches to 0 from the right. So if we plug in 0 in the x, that would be 0, and then the natural log as x approaches to 0 from the right is minus infinity. So we have 0 times minus infinity. LHospitals rule won't work on products. It only works on quotients, so we're going to rewrite it into fractions. So we have here the limit of x times ln x as x approaches to 0 from the right is equal to the limit of ln x over 1 over x as x approaches to 0 from the right. So if you encounter 0 times infinity, you write it as a fraction by writing 1 over 1 of the function. So we have here 1 over x. So now the limit is in the form of negative infinity over infinity, and we can now use the LHospitals rule. So I have here the limit of 1 over x divided by negative 1 over x squared as x approaches to 0 from the right is equal to the limit of negative x as x approaches to 0 from the right. So the final answer is 0. So that is for the type 0 times plus minus infinity. For the type infinity minus infinity, we have here the limit of 1 over x minus 1 over sine x as x approaches to 0. If we plug in 0, we have 1 over 0 minus 1 over 0 that result to infinity minus infinity. So the strategy for this is to combine the two fraction into single fraction. We can combine the two fraction by cross multiply. So 1 times sine x is equal to sine x minus 1 times x equal to x. Then multiply the denominator together, so we have x times sine x. And then if we plug in the 0, it would be 0 over 0. And now we can use the LHospitals rule. So we need to get the derivative of the numerator and denominator. So the derivative of sine x minus x is cosine x minus 1, and the derivative of x sine x is sine x plus x times cosine of x. We won't stop here because it still result to indeterminate form 0 over 0, so we need to use LHospitals rule twice. So the derivative of cosine x minus 1 is negative sine x. The derivative of the denominator is cosine x plus cosine x minus x times sine x. And then we need to simplify this, so we have negative sine x over 2 times cosine x minus x times sine x. Again, simplify, so we have, if we plug in the 0, we have here the 0 over 2. Our final answer is 0. So that's it for this video about indeterminate forms 0 times plus minus infinity and infinity minus infinity. If you have any questions, clarification, and suggestions, kindly comment it down below.